Hi everyone, my name is Lino. I'm from Brazil. I'm actually from the Laboratório for Environmental Satellite Applications. I would like to thank the CCI for the opportunity to be here and show a little bit more of our work. It's going to be nice to show people that already know me and the ones that don't know me what we have been doing in the lab. So our lab, it's actually in the Federal University of Rio de Janeiro. Federal University of Rio de Janeiro is one of the biggest universities in Brazil. It has about 60,000 students, and plus staff, it's going to be like 100,000 staff, and faculty is going to be like 100,000 people. So it's like the style of, it's the oldest university in Brazil. So it has like this huge amount of students and faculty members. So it has sort of different departments. We are under a meteorology department. So our lab is under a meteorology department. We are within a geoscience institute, and there's like also like a center for mathematics and environmental science. So the topic that we have been working on, it's completely related to climate change. So the idea here is to show how we have this interface with the CCI, okay? So here's our heads, actually, Dr. Renata Libonati, Dr. José Ricardo França, Dr. Ana Nunes, myself, and Dr. Leonardo Paris. Actually, I'm the most recent one. I'm in the lab for the past 6 years, since 2018, more or less. And we have in our lab around 50 people, around undergrad students, master students, PhD students, postdocs, and visiting researchers. Okay, so this is a little bit of the expertise of each one of us. So there's all of us are somehow related to remote sensing, but some of us are more into climate studies. Here, Professor Renata has a wildfire experience, climate extremes, climate and health. Professor José Ricardo, it's around more aerosols, clouds, physics of climate. Professor Leonidas, it's more like a climate modeling and climate change. Myself, it's a remote sensing applied to water resources. And Dr. Leonardo is more like a remote sensing urban climate health person. Okay, so our goals in the lab are a lot about teaching, research, innovation, and we do a lot of outreach too. So I will have the opportunity to show here what we have been doing. I hope to not just advertise the lab, but show a little bit of what we have been doing in science. So what are our main focus? So of course, we are a remote sensing lab. We have been working a lot with wildfires and climate extremes. Water resources, like I said, is more like a recent thing. Numerical modeling, urban climate and pollution, climate and health are things that we have been focusing a lot in the past years. So this is not to be flashy, it's just to show you what are actually the type of research that we have been doing. So Professor Renata has put a lot of efforts in understanding compound effects in Brazil. So droughts related to heat waves, related to other events that can be the reason of most of the wildfires in Brazil. Brazil has burned a lot, and it's, I'm gonna show you what are the efforts that we have been doing scientifically and operationally, I mean, with platforms to monitor wildfires, areas that have been burned. So, and the impact of that in health and fire, in health, and actually in other biomes in Brazil. Okay, so this is what we call here wildfire and climate extremes. This is what I have been doing during my PhD. I was actually here in the University of Maine under Emmanuel's supervision for a year, 10 years ago. And so I had the chance to look into a little bit more on the data that I collected in the Amazon. So there's some work on that. We have been part of some other strategy to validate remote sensing. And also, this has been a lot of effort to build a community in South America. So I have been working with people in Argentina. These are just two papers that we got in the Cartagena Bay in Colombia. I have been also working with lakes in Brazil. I'm going to show a little bit of that. And those are just two works that I've been doing, have the pleasure to be part of from the University of Maine. Okay, we have worked a lot in improving models to look into burn area in Brazil. So there are a couple of works here. Actually, one of those works are actually this one. It's the core of the system that we have today in Brazil to monitor wildfires. And yeah, and we have, so I'm going to show a little bit more of that for you. So this is a remote sensing, what we call here the natural hazards. And some work in urban climate, monitoring urban heat island in Brazil, the impact of urban heat island and heat waves of urban heat island, how that translates to impact of heat energy fluxes in different cities in metropolitan areas of South America, and how that relates to climate and health. So those are some of the work that people have been doing that actually are related to heat stress and mainly respiratory disease. So I'm going to have the chance to show some of that work. So our international partnerships, I'm going to show you there that's what we have been trying to do. We have a national and regional projects, and particularly third-party funding, working with NGOs, yes, to have funding to mainly for the systems to monitor fire and pollution, and now we have started working with some of a water quality outlook. So we are proud to have different partnerships. I have the pleasure to go to Mozambique in 2023 to teach a course there. We have established a partnership with the LASA and some universities in Mozambique. Like I said, we are pushing hard to have more collaboration between our countries in South America. So I have been working with Argentina, Chile, Ecuador, Colombia, and Venezuela. This is actually really good because we can apply together for funding. It's much easier to get things done when you have partnerships, a local partnership. But of course, we have partners in the US. So Professor Renata and Professor Leonardo, they have been working a lot with people from Maryland because they are experts in fire. And of course, I have the partnership here in University of Maine. Professor Ana Nunes was for, I think, 14 years in the Scripps Institute. So she has some partnership with NOAA, NASA, and CAR. Of course, Canada, Australia too, and in Europe, because three of us, Professor Renata, Leonardo, and José Ricardo, they had their PhDs and postdocs and worked with the researchers, mainly with France and Portugal. Actually, our PhD program now, it's like, how do you call that? When you have two, you can get a PhD from a country, from an institution and another one. How do you call that? Like a joint, yes, joint degree. So we have a joint degree for with the University of Lisbon. So we have 2 or 3 students that already finished a PhD, which is really good because Portugal is it's an expert in fire too, so they kind of get together to work on that. And of course, there are other partnerships that I'm just pointing out here due to the type of work that we have been doing. We have the pleasure to be part of the State of Climate in Latin America and Caribbean for the WMO. And this is spreading like wildfire, which is a UN program that we have been collaborating a lot, mainly in Brazil, of course. Okay, and again, we are trying to have more like joining forces with the civil society and academia. So those are some of the, is it NGOs? Yeah, that have been supporting mainly the fire program in Brazil. So we thank that a lot, and we keep like doing that. Sometimes it's really hard to get money from the government to do the right thing in the beginning. So we have been pushing hard for that. Okay. So what are the innovations that we have been doing? So there are three here. Of course, the biggest one is the Alarmis platform, which is fire monitoring. It's the main platform for burning area in Brazil nowadays. Fortunately, now we got from the Ministry of Environmental Ministry and from some of the institutions that are that really need that, especially on this time of the year, from July to September, October, where fire in Brazil just left. It's really hard. And we are pushing hard to have like a similar platform for water quality and a similar platform for urban climate. Okay, I'm gonna show a little bit of that. Okay, so I'm talking fast because I want to get to this. So there are 3 or 4 works here that I'm gonna change what is the line of research that the lab has trying to go into. So Professor Renata has worked hard to show mainly during the 2020, where the Pantanal wetland burned, almost half of it burned, which is, so the Pantanal wetland is the biggest wetland, continuous wetland in the world. And so that started to be like to push hard to find funding to monitor this area in Brazil, but also to show how that can be a big problem. So actually she has coupled that with heatwave studies to show that this drought, heatwave, and some other factors has actually forced the type of fire that we have been having in Brazil. So this is a comprehensive review that we had. Professor Renata talked about it, wrote about it, which is this drought heatwave nexus. So here in Brazil, this area is actually the Amazon. This is the most known, but that other one here, it's what they call it the Brazilian savanna. We call it Cerrado in Brazil. So it's the area that it's most burning in Brazil. And this part here, this is the Pantanal wetland. Okay. So there are several works from our group that have been showing that the drought heatwave nexus actually it's improving. You have even more and more fires due to this climate change events. So like I said, in 2020, most of the Pantanal were burned. The government had a really hard time to focus on mitigating that. This was a little bit during the COVID time, so that actually was even a bigger problem at that time. So then we had funding from Greenpeace, I think, to start having the system to actually show people to where are those areas that in Pantanal they are burning a lot, right? So that event actually triggered other types of problems that I'm going to show you here. So in 2020, you have unprecedented drought and heat wave events on Pantanal area. So this is like a plot of the number of heat waves and the temperature anomaly that were mostly and they are increasing actually in the recent years. So you had heat waves, you have drought, you have a decrease in precipitation, you have the soil humidity with extreme and negative anomalies. And again, like no precedent extreme heat and heat waves in the environment. So that triggered fire and make it burn most of it. And what the group has been trying to do, it has been trying to understand what could be the impact of like a compound dry hot fire event can affect other areas in the country. So all the burning that had in Pantanal, there was an impact on the São Paulo state. The São Paulo state is the biggest in population in Brazil. It has about 44 million people, and the São Paulo city, which is the biggest in population in South America, has about 20 million people. So this study actually tried to model all the smoke that went from the Pantanal burning up to the São Paulo state and São Paulo city. So there's a couple of runs of modeling. And what actually we could see is that there was, here is March, May, July, August, October, and December. So the smoke that went from Pantanal actually increased a lot the PM 2.5, which is data for particle matter, particle size matter in the atmosphere. So it increased almost 600% above the OMSS standards. And in that period, we could see from the modeling and from the observational data that there was, and it was coupled with the fires in Pantanal. So something that went up to 1,500 kilometers actually impacted the biggest population in Brazil in a bad way, actually, because we could see that coupled with that, there were some temperature anomalies. There were some heat waves in São Paulo state from 7 to 12 days. And we could see that after that, we could see a 20% increase in human deaths in the São Paulo state. So this is actually a mixture of climate change, the increase in heat waves, the whole, actually there's something here that helps me to explain that. So there's a compound drought heat waves that triggers fire. And for a long range of smoke transport, you can have like air pollution increasing a lot. And with the heat waves, you can actually have a regional impact that exceeds in that sense, that exceeds 2,150 deaths. So I think that's a very nice way to show how the lab it's looking for coupling meteorology, remote sensing, health, and air modeling, for example. Okay. All right. So for the remote sensing and natural hazards, like I said, we have this Alarmis wildfire information platform to support fire prevention, management, and suppression in Brazil. So it started just in Pantanal in 2020, and nowadays we've fortunately got the funding to have it for the whole country. So actually we are able to monitor fire burned area in the whole country. This is actually tricky because the environments the biomes are different. So the type of fire that you can have in the Amazon is actually very different from the Brazilian savanna. So actually you have to have a model from remote sensing get the burn area in different parts of the country. So for the past years, we have been working a lot on that. So actually, this is the platform. If you have a cell phone and can take a look on that, it's a brand new one, fortunately, and it's been operational for 5 years. Sometimes it's really hard to get that being in a university because you have to be able to have an operational system in a university, and there's a whole bunch of problems that you have to tackle from like the power supply that is off to being able to have persons specifically to develop that. So this has been developed all in the cloud. So all image processing, all of the application of the models, all site development, it is all in the cloud. So we can make sure that we can have the system all the time, because this is tricky, especially in this time of the year. You have to have the information like one day before or in the same day, right? So we are not able to have the system not working for that period of time. So what was the difference here? We actually provided geospatial analysis data products and service to support fire management. So there's a near real-time and historical burned area monitoring. We support the prescribed burning for stakeholders, which is actually really good. We are actually making a capacity building, and we can have a fire weather danger forecast too, which helps a lot for some state and national things that we have been doing to prevent the fire monitoring. So how was the problem before 2020? We just have a monthly annual information on burn area. So we actually had a delay of 3 to 6 months. And the alarm gives you a daily information, which is very important for state power to prevent it. So how it works? Actually, we have this WebGIS and the dashboard platform. So this is more or less this. For example, this was the 2020 all burned area in Pantanal. And we actually have a citizen science strategy to have validation. So people can go in places where you have from that area, they can like take a picture of the fire working and having at this exactly time. So they can upload that to like we call it Phototech, it's like a library for fire events. And we can have that in the dashboard and in the WebGIS at the same time. So we're kind of working a way to validate the system that we developed, okay? So, and this is our fire weather danger forecast. Actually, it takes the information from the burn area, the information for active fire that we have in the previous day, for example, which is like September 16, for example. And we have a numerical modeling, we have the forecast, and we can have like 5 classes of low, moderate, high, very high, and extreme chance of have fire. So here, for example, muito alto, it's actually very high, and here is extreme. So the firefighters that are in that region, they can look into it and be prepared for that. So that's the whole idea behind this system, okay? This is just a wildfire management tool. This was built with the state power from one of the states in Brazil that is the state that most burns in Brazil. So they can have a system that they can monitor if the type of burning are legal or not legal, right? Because there's a lot of illegal burning in Brazil, unfortunately, okay? Okay, so this is just a note, Google Analytics. This is just like people using the system in the world. And those are just, I'm gonna translate that for you because this is important. This is the environmental ministry in the federal agency. Those are both institutes to take care of the environment in Brazil, but prevent fire. This is the main national system in Brazil to take care of fire in Brazil. So they looked at our system, the alarm system, and they can say to the local firefighters, so where they have to be to prevent or take care of not having more fire in Brazil. Those are all firefighters from different states in Brazil. This is the, how can you say that? The legal, so there's, okay, so since there are a lot of illegal fire in Brazil, you have to have the law working on that. So this is I don't know how to explain that, but this is part of the legal system in Brazil working together with the firefighters and the whole ministry to, if there is a crime, they can trigger that, and with alarm system, people can see if that was actually what was happening or not, right? So we are helping legally with the thing too. Those are all other systems to prevent fire, okay? So those are the end users for our system. All right, so, and due to that amount of fire in Brazil and heat waves that we have been showing, there's a part of our lab that is working a lot with climate and health. I don't know if you remember, is there any, oh, what is the name of that? Singer, very famous singer in Brazil. So there was an event, the singer from the US, say a name of a very Victoria. No, where's the name of that singer? Very. No, it's just singer. Sorry. Yeah, what's the name of that very famous singer in the US? The most famous one. Taylor Swift. So Taylor Swift went to Brazil, and there was a show, and in Rio, and actually there was a heat wave event in the same time that there was a show. And unfortunately, because of heat waves, there was death. A person died. So that actually, it was like the right moment, unfortunately, actually, so we could talk about the heat wave frequency in Brazil. So heat wave frequency in Brazil, it's increasing a lot. So those are all state capitals in Brazil, which are the biggest cities in Brazil. And this work actually showing that we are increasing the number and how severe and extreme are the heat waves per year in Brazil. So Rio de Janeiro, which was one of those ones, actually, it's not compared to other places in Brazil. It's not that bad, but it can be bad enough to have an impact on the population. And actually, the impact of the population is that the heat-related death in Brazil, which was 50,000 from 2000 to 2018, they are 20 times higher than the landslide fatalities nationwide. Why I'm saying that? Because landslide fatalities are actually advertised as the biggest environmental related fatality in Brazil. And people, especially in the media, it was really interesting because every time they talk about heat in a tropical country, which is already very warm, they go to the beach and do like the reporter go to the beach and say, hey, it's really hard today, but see how people are in the beach. And that triggers, actually, it was really interesting because Professor Renata went to an event and gave a talk in a journal, right? So that actually changed the way that the TV station, I mean, the media talked about the heat waves problem, the heat problems in Brazil. So nowadays you don't see many people going to the beach anymore and say, hey, this is not a problem. Actually, people are looking into it, and there are more and more talk about to show how heat-related deaths in Brazil are a problem. And this paper actually showed very interesting results. So one of those results is that the type of what you can have, like in different parts of the country, you have heat-related deaths that could be related to circulatory and respiratory disease, tumors, skin disease, mental disorders, digestive, etc. They are all triggered by heat-related issues, right? And you can see that this is an impact, for example, and it impacts disproportionately elderly. There are more women that die because of these heat wave events than men. This is one thing. This is above 65 years old. You have scolarity factors. You can see that in the country, I mean, Brazil is a very unequal country, so this is kind of expected, but to heat-related problems, you can have low scholarity people dying more when related to high scholarity people, and you can have the racial disparities. So you have black and browns in Brazil are dying more due to heat-related issues. So you have a higher relative risk for black and brown individuals. Why that's important? Because when the state power goes and have some specific actions, they can trigger different population. They can have specific actions depending on the group that those populations are, and it can be helpful, right? And now, so the next thing that we are focusing on is on the prematurity and the climate crisis here. We are actually looking at heat waves and see how heat waves can be a problem for a number of premature so in face of this whole heat-related problem. So this is, we actually have the problem, the project, but we are still working on that. So there will be like a paper in the next months. Okay, We have been working a lot with Human Heat Island 2. This is the Rio de Janeiro. This is so you can see that from 84, this is all Landsat for people that like Landsat, like Tom. So this is all Landsat work. So we can see that there is an increase in land surface temperature across the year, so that you can see that people that live. So for people that who don't know Rio, okay, so in this region, you have the Ipanema and Copacabana beaches, actually. So if you go to this part of the city, you can go up to 50 degrees Celsius in summer. Yes, you can, right? So that's the problem. So, and of course, that's the people that have more money, they live here. They don't live in the very warm places. So again, this can help the state power to do some help people to have some and that happened actually because of papers like this showing where people have to be more cautious about temperature and heat issues. We have expanded that to South America. So this is a paper that was published. This is 2020, last year. There was a heat stress in a lot of South America cities. Those are all cities in South America. Most of them are in Brazil, but they are like from in Argentina, there are in other countries, and you can see that there is an increase actually throughout the years in the number of heat stress in those cities. So this is actually a problem, okay? And we have been trying to not as the Alarmis platform, but we have been trying to have a platform for heat and heat stress in Rio de Janeiro. This is we call it climatology, right? It's just a climatology, so people can go to this platform and be aware of what are the heat-related problems that they can be faced depending where they live. So this is gonna be a little bit of what I did. So for the ones that don't know me so much, so I did some during my PhD. I did some work in the Amazon, so I came here to, fortunately, with the help of Emmanuel, understand some of the data that we collected at that time, so that there's some work that I did there, and mainly remote sensing to develop models to have turbidity in such a very high turbid waters. Nowadays, since I'm in Rio, I have been focusing on coastal areas. This is the Guanabara Bay, the famous Guanabara Bay in Rio. So we have looked into the climatology of turbidity and how it depends on tides, for example. This is was just recently published. And other bays, like this is they call it Sepetiba Bay. It's highly impacted by ports that are around here. There are an increase in metals because of the whole industrial area that is around it. So we have this climatology of turbidity and sorry, for total suspended solids in here. We are characterizing more. We are going to field campaigns to have even better models to develop here. This is just like a 20-year climatology of turbidity, okay? And those are the works that I told you about, that I'm working in the Cartagena Bay in Colombia. Those are, is the Itaipu Reservoir is the one for the biggest hydropower in Brazil. It's been a little bit impacted by environmental management. This is a very interesting study that I had the pleasure to co-advise with Professor Thalita in Brazil, which is looking into restoration measurements in a very turbid lake. It's very interesting because they have been trying to very local and chemical ways of decreasing the amount of algae and of algae that can be a problem for health, right? here. So it was really interesting because we got a series of images for remote sensing, and we could see that when they started the treatment, actually decreased the amount of algae, right? But then the funny thing about it is that there was like a political problem against it. So one of the companies that was actually related to the state power, it went to a big law dispute. And actually this paper was a scientific way of showing that what they were doing was actually making a difference in the lake or not. So this is another way of using science to prove a point in that sense, okay? And again, we are working on this Alarmes Agua, Alarmes Water, which is a remote sensing platform for water. This is not even close to the other Alarmes fire event, but platform, sorry. And but we have tried two approaches. One is we call it Alarmes Agua, which is more focused on the coastal area. So we have a bunch of images here, and we have some models to monitor the concentration of chlorophyll A or TSS or turbidity. But with that, we actually have our own system in the university. So we downloaded all the data, we treated all the data in computers in the university. So that has been working well, and it's better, but it gives the problem that you always have to download data and work on data and have it in your own cloud that you have to pay for it, or like a system in your university. What I have been trying to do before is this other platform that was all Google Earth Engine idea. So we would not have to pay for a cloud. We would not have to pay to a host. But the problem is we don't have all the products here. So this platform is actually a little bit better developed. It's focusing on lakes on the state of Rio de Janeiro. It has like, this was really focusing on the state agencies in the state that are looking for environmental problems. So it has to be fast. It has to be to give a response, because the guy that is in front of the computer doesn't want to wait for to download an image or it has to be fast. It has to give the information quickly. This person sometimes is not actually looking on the real quality of how good you are estimating turbidity or chlorophyll, because they are actually looking for very high values for that. So this is what we have been trying to, and there are people in the state that are using that. And one of those examples is actually this one. So this is a reservoir, right? That it's responsible for the water. How do you say that? Water gives water to people, treatable water, right? To 1.5 million people that live here. Okay. So this reservoir went through. This is really recent. So this is from May up to September. We have this really hard algae bloom, which is actually toxic. We went to the field campaign. We were able to, using the satellite images, look for harmful algae blooms. And there is a problem actually. And we are developing the algorithms to retrieve chlorophyll. We already have it. We just don't have it for the harmful algae blooms. That is a little bit more of a step for that. Okay. So what we have for the next step for the water research, we have actually 3 projects that are already working. So one of them is the overheat, which is funded by the Brazil National Funding Agency. And this one and the challenge of human exposure to extreme heat, we are going to be looking at the impact of heat waves on the water, right? On the coastal, on lakes, and to see how that can impact the water quality in Rio de Janeiro, the coast of Brazil, and maybe in the Atlantic Oceans with people from Portugal that we have been working with. And there is another line of work here, which is to build a tool to show the impact of fire to the water quality in Brazil. So to have an idea of how much it burns and how much it can impact the water quality. Okay, this is funded by several national funding agencies. We already have a paper on that. This is just a very simple model for using remote sensing to have like places where you have to be careful more and less depending on if it's burning or not. And finally, what I'm doing here. So thanks to those guys here, I have the chance to come, and fortunately I got a project approved. It's the first one, I hope so. Some of them. So to build a ship-based continual optical data acquisition systems that I put it like the CONTOPS. So the first step here is to learn, of course, with Emmanuel, Guillaume, Niels, how to build those systems. Of course, you do it in a much nicer environment. This is the Tara has been going all around the world with a continuous system to measure optical properties. So my idea is not to have like that beautiful fancy boat. It's gonna be a smaller boat, so we can have like an inline system to measure inherent optical properties and PISA system to measure remote sensing properties. This is here. See here? This is you here. Okay. Oh, stop. No. Right. So the idea is to, like, in a couple of years, to have the capability to be able to measure in high resolution data collection for inland, coastal, and ocean waters in South America. So we could be like a base or like at least a start point to have good data collection in South America, because this is actually a problem, because there are not so many ways of measuring that in South America. So I hope to be able to help a little bit on that. Okay, and then finally, we have an outreach. We go a lot to the high schools. And what's the name of schools before high school? Fundamental? Elementary schools. Yeah, we have been doing that a lot. It's actually a fantastic experience. It's amazing to see how children are interested in different types of the work that we have been doing. It's actually very challenging because we have to adjust our way of talk to those guys. So we have been doing that a lot. It has been, it's an amazing experience. This is just I wanted to show you guys because this is something that so as a professor in the university in Brazil, nowadays all the courses have to have 10% of this whole how to say that? The whole time that you are in the school, in the university, 10% of that has to be part of an outreach or an extension project. You're forced to do that. You actually have to do that. So when I started in the university, I had a very good friend here. This is Rafael. He's a very knowledgeable mountaineer. He went to very high mountains, not just in Brazil. He went to Chile, Argentina mountains. What is the name of it? So there are the 7 peaks. I don't know if you know about this. So he has been in 3. He has been in Africa, Europe, and Aconcagua. That's in Chile, Argentina. And his next one's probably gonna be the one in Alaska. What is the name for it? Yes, this is the highest one in the North America, as I understood. So I had the chance to be working with this project, which is like a meteorology and mountaineering. We have this, it is actually a center for mountaineering in Brazil. It has almost 100 years old. It is amazing how much of mountaineering you can have in Rio. It's actually a very nice place for climbing and for mountaineering. So I got the students to help with those guys that go for mountaineering, and it was a very interesting experience. It's very nice to see how people in mountaineering are. They want to understand things in meteorology because they need that a lot. And for the students, it was really nice because they learn things in school and they have to explain to those people, and they kind of know a little bit, but not so much. So it's been like a very nice project. It's been like for the past 5 years. We have briefings every time that they go on an activity. We provide them the briefings, and then we go back to the center. We discuss the meteorology aspects of it. those are some of the places that we have activities that we provide briefings in Rio and in the Rio de Janeiro state. This is just a part in Brazil. So I hope to keep going on that. It's been a pleasure actually to work on that. And finally, I've been trying to, and we have been trying to do like make this lab fun to work. I've learned that a lot with Emmanuel. So these are just some pictures that we have in the lab. Brazilians like to make fun a lot of each other in the lab. So this is just one student. I was just trying to see if I could get a cable like 2 months ago. I was talking to Niels about it. So when I was asking him all the time, please take a look if this cable fits. I'm not sure about it. Take a look. And when he got it, he just like make this nice face just to see that the cable just fit to the other one. So this is the thing. So this is actually our group who are in just a party in the end of the year. So we really hope to have this very nice, fun environment to be working with. That's it. Sorry to talk so fast, and thank you very much for being here. Anyone has a question? I don't know if we still have time for it. Oh, we still have. If there's any questions. Yeah.
Thank you for the presentation. I'm not so familiar with remote sensing, so this might be obvious to other people, but what is the boat aspect contributing to the satellite? Or are they connected?
The boat
that you were making with Contops?
Okay. So yeah, so it's good because there's some people here that could be even help me to it. So the idea here is to, in a remote sensing perspective, of course, there are a bunch of other ways of studying the ocean with optical properties. And there are 2 types of properties here, what we call inherent optical properties, that are how much the water and the things that are in the water absorb or scatter light. These can be related to what we are measuring here, which is a remote sensing reflectance. It's the amount of water that you measure in the satellite. You can measure actually in a system like this. So the idea is to have both the inherent optical properties and what we call apparent optical properties, and relate them to be able to build models on afterwards in the satellite imaging. How we can apply models that we take in situ, we can apply to the remote sensing images, right? But of course, you can talk to all of those guys. Yeah, they know a lot about this if you're interested. They have been doing that for the past 10 years. Yeah, so there's a bunch of papers from Niels, Guillaume, and Emmanuel that works with the kind of inline system all around the world. Okay. Did I answer you? Okay. Any other question? Yes.
You've been using PACE. You think the aerosol part of the but yeah.
Well, I think for the aerosol part. Well, as I understood last year so there was a class for learning how to work with space measurements. As I understood, the aerosol measurements are they're still working on it, as I understood. So there are 2 systems there, and I'm not sure if the products are available in the website yet. Right. So I don't know. Have you guys looked into the PACE aerosol for now? Not yet. Well, Patrick's not there. The products are there. The products are already there? Okay. And I think they were checking how the quality of it yet. Actually, there's one system which is I'm not sure about it. There's 3 systems. There's 2 for the regular and reality. Yeah, but I mean the for aerosol for the. Oh yeah, that's true. Yeah, you're right. Yeah, sorry. I was thinking just in the polarimeters. Yeah, there's the OCIT. Yeah. So I don't know if we can answer more than that. Sorry. Any other questions? If not, thank you very much. Oh, that's all. Thank you. Thank you very much, guys.